Oh, Ben, in the Word document, we just need to write our names.
I can put them in if you want, or you can type them in. It's up to you. It's shared.
Okay.
I wasn't gonna probably put it in until Saturday, anyways. By the way,
Okay.
I don't do schoolwork on Fridays, so
Thank you.
okay. Here we go with the quiz.
All right.
Okay.
I think we're gonna want that and this. Okay. Okay, who wants to go first?
I'll take it. The symbol for the true population proportion is which of the following? And it's the last one. P.
I agree.
Okay. Agree. Okay. I can take the next one. For the next two questions, suppose N will be 100 and P 0.25 and P hat 0.10. The requirements for constructing a confidence interval are satisfied. Okay. We need, I think, I think it's true.
Yep, I agree.
Okay.
And so for the one you use the 0.25, and for the other one you use the 0.1. And to do your confidence, I mean your formula. And so the one's quite a bit over. This one here is just barely. It's at 10. But since it can be 10 or over, then this next one's true as well.
Okay. Okay.
The study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of this, 45 of the defendants were found guilty. Find P hat the point estimate of the proportion of first-degree murder defendants who were found guilty in this state. Round to 3 decimals. So since we have the sample 60 out of 45, and we'll do the p hat formula, 45 divided by 60, which is 3/4. And in decimals, I think we have to put the 0. Will it be a 0 after the 5?
I don't think we have to do that, but we've still rounded to 3 decimals.
Oh, okay.
Okay. Create a 95% confidence interval for the true proportion of first-degree murder trials in this state where the verdict is guilty. Input your answer for the margin of error, lower bound and upper bound. Determine the margin of error for this 95% confidence interval. Okay, here is where we use our, okay, one sample is test for a proportion. So the 95 confidence interval is there. We just need to change the X and the N, right? Can you go up, please?
Sure. Where do you want me to go?
In the left, the information to write in. Okay, but I didn't write the numbers. uh, can you go upper and question 6, please?
Oh, I'm sorry. Yeah.
Okay, our sample of 60, it's our N, okay? And yes, I agree. And our confidence interval will be the lower bound, 0.640,
So,
and our,
right. So you answered this one right here, the lower bound,
Yeah, you.
yes,
0.640.
okay,
Yeah, we can understand. And then the upper one,
0.864, sorry.
It's okay.
260.
That was it. Yeah.
So now we can do the margin of error here.
Oh, okay.
Do you remember how?
Um,
Oh, I don't remember.
So there's a formula for margin of error, but if you have the Excel spreadsheet, you can just take the upper confidence interval minus the other and divide it by 2.
Oh, I get it. I remember now. Sorry. It would be minus 0.11. Okay. Minus, right? No.
No, it's
Oh,
actually
no, no.
positive. It was this
Okay.
0.860 minus 0.64, which was 0.22. Divide by 2 is 0.11.
Okay. Okay. Thank you.
Is it my turn?
Okay.
think it's mine.
Okay, go ahead.
Is that 10? Okay. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? So it will decrease.
Right. Less room for error, the bigger the sample size.
Okay.
Okay, next is to conduct a hypothesis test for one proportion. 2 requirements must be met. Suppose P is equal to half. What is the smallest N can be, and both requirements can still be met. So all you have to do is take the inverse of a half and times it by 10,
By 10.
and you'll get your number. So that's 20. Because remember, it has to be greater than or equal to 10, both those numbers. So that's 20 there.
Okay. I agree with you. To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1/10. What is the smallest N can be and both requirements still be met? Okay. In that question, should we use the formula to find our N,
You can, yeah.
or just
Just do the same thing as the other one.
Yeah, the same rule applies.
Yeah.
oh, just 10 times 10? It will be 100.
Yeah.
Yeah.
Yep.
Okay. Thank you. Okay.
So for the next one, for the water quality study in the reading, about 60% of the microvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conducted a hypothesis test using significance level alpha equals 0.05, which the following hypotheses, hypothesis P equals 0.6, and then greater than 0.6. They collect new data in this time, n equals 80 and x equals 38, indicate good health. So the question is, the conditions for conducting a hypothesis test are satisfied.
P.
Okay. Well, I think it is true. Doesn't it have to be in no greater than 100?
Yeah. It's n times p is greater than or equal to 10.
Okay.
Right? And so that's 80 times 0.6, 48.
Mm-hmm.
And then it also has to be that n times 1 minus p, so n times 0.4.
Great. Okay.
Okay.
So you said true,
That is
right?
true. Yeah.
And then I put in the information over here, 38 for good health, 80 N, 95 confidence level, and then the null hypothesis was that they were at 60, and we're trying to do less than 60 is the alternative hypothesis. So the p hat, I believe is what it's asking for,
Right.
is 0.475.
Mm-hmm.
Okay. Find the test statistic. It would be minus 2.282.
Yep. Okay. What is the p-value for this test? Go to the
It's right here too, by the way.
oh, jeez. 0.011.
Okay.
And because that's less than 0.05, we're going to reject the null.
Since we are rejecting, if we reject, we have insufficient. There we go. Right.
So if we're rejecting the null, what are we doing with the alternative hypothesis, even though we don't normally say this?
We okay, we have sufficient evidence. There is sufficient evidence to conclude that water quality in the area has decreased.
That's what I think it is too.
Yep. Me too.
Okay. I think that's it. Here we go. Okay.
Awesome.
Great.
Good
Thank
job,
you.
guys.
Too. Thank you. I wonder